Fringe pattern projection. In the previous section, we described several acquisition methods for capturing images from a camera in LabVIEW. However, in fringe projection systems there are many different fringe pattern projection technologies, and choosing the correct one becomes extremely important for an accurate three-dimensional reconstruction. A fringe pattern projector can be considered as an analog device, for example, LED pattern projector, or as a digital device, for example, DLP, CLCOs, and LCD digital display technologies. LED pattern projectors are ideal for high-resolution three-dimensional reconstruction applications. If equipped with an objective lens and a stripe pattern reticle, these projectors offer great versatility for manipulating the optics of the system and obtaining results according to the metrological requirements. The main disadvantage of this type of projection system is the impossibility of manipulating the projected fringe pattern. Therefore, its use is often restricted to techniques in which only a single fringe image is necessary to obtain the 3D information, such as in the case of FTP. Fringe projection systems can also take advantage of a computer to generate sinusoidal fringe patterns that are projected using a digital projector. The key to a successful 3D reconstruction system based on digital fringe projection focuses on generating high-quality fringes to meet the metrological requirements. Ideally, assuming the projector is linear in that it projects grayscale values ranging from 0 to 255, 0 black, and 255 white, the computer-generated fringe patterns can be described as follows. Where PD represents the number of pixels per fringe period, phi refers to the phase shift, and ij are the pixel indices. 16 is implemented using the numeric functions provided by the LabVIEW base package. An example of a pattern generator block diagram is shown in. In this program, the numeric indicators enable the modification of the fringe pitch and the phase shift according to the application requirements. Block diagram for fringe pattern generation. An alternative to a block diagram implementation of 16, LabVIEW provides a MathScript-RT module as a scripting language. The module allows the combination of textual and graphical approaches for algorithm development. We provide an example on how to use the MathScript-RT module for fringe generation in LabVIEW. Fringe pattern generation example using the LabVIEW MathScript-RT module. Once the fringe images have been generated, they are sent to a digital video projector for projection. A video projector is essentially a second monitor. Therefore the fringe image is displayed by using the external display vise provided by the Vision development module. Here, we use a MacWinDraw VI to display the image in an external image window. The image window appears automatically when the VI is executed. Having beforehand the information from all the available displays on the computer, including their resolution and bounding rectangles, we set the position of the image window to be displayed on the desired monitor. This setting is done with a MacWinMove VI. Additionally, using a MacWin setup VI, the appearance and attributes of the window can be modified to hide the title bar. Note that the default value for this attribute is true, which shows the title bar. The block diagram illustrates a projection stage in LabVIEW. Here, we use a property node for obtaining the information about all the monitors on the computer. The disp.allMonitors property returns information about their bounding rectangles and bit depths. Second monitor configuration in LabVIEW.